and share my screen. Okay, so everything is in order, right? You can see.
Yes, sir.
Yes, sir.
Okay. Okay, so today we will start a new topic, fairly important and interesting one. I see. Anyway, I've changed the color. Functions. Okay, so you recall that in the very first class, we have seen something like two ways of computing the area of a triangle. Okay. So this part, as you see, this is what is called a function. It's an independent entity. This is also a function. This is also an independent entity. And this is meant for doing some job. Okay. Also, you recall that in any program, you must have a function with the name main. Okay. So a function is something like a subroutine which is meant for doing some specific kind of job. For example, here, this area 1 is the name of a function of this function, and it computes the area of a triangle specified by the x and y coordinates of the three corners. Okay, x1, y1, x2, y2, x3, y3. Inside it, it uses this formula and returns this value. Here, yeah. Yeah, any question? No, I do not hear anything. Anyway, this is another function with another name. This also takes some input things and it computes the area in a different, using a different formula and returns that thing. Okay. So in general, a function looks like this. You have to specify the return type. This is followed by a function name. Then, within a pair of parentheses, you have a comma separated list of what we call in this context arguments or parameters. They are also called parameters. Then what happens? You have an opening brace, a curly bracket, and a closed curly bracket. And in any type of function, even if it consists of only a single statement, these curly brackets are necessary. They are not optional. Okay. So they are not optional. Necessary, mandatory. Okay. And within this pair of braces, you have what is called the function body. Okay. Now, what does this function body consist of? Three important things. some local variables, and then you have the actual code, the instructions that work on these local variables, on these variables, and a set of assignments or instructions. And at the end, you have some return statements. So this is the basic way a function is organized. Let us see that this area 1 and area 2 functions do have all these properties. Float, it will return something of data type float. The name of the function is area 1, and when you name a function, you should follow the standard naming conventions of C. And then you have a comma separated. This is not semicolon separated. This is a comma separated list of the so-called arguments or parameters. So here it says that x1 is a floating point argument, y1 is another floating point argument, and so on. You can have any mixture of different types of parameters as appearing here. Okay, and then this is mandatory. This brace is also mandatory, opening, closing brace. Here I declare t as a local variable, so this t is a local variable, and then I do some kind of computations. Okay, something like this. Of course, in this case, I have a simple, not a very complicated computation, but it can be very complicated. But that's a different thing. And at the end, you are returning this t, whatever value you computed in this local variable t. Here also, you have the return type float. Name is area 2, and you have a comma separated list of 6 floating point arguments. Here I use 4 local variables a, b, c, and s, and then I do some kind of computations. Okay, and eventually I return square root of s minus a, s minus b, s minus c. So this is the basic structure of any function. Okay. Maybe. Okay. So one by one, let me highlight several things. Return type. Okay. So what can it be? So it can be any valid C data type, like int, float, char. Arrays for the moment, let us not too much worry about. It can in some way return arrays, but for the moment, let's not worry too much about that. I will tell you how to handle arrays. And if you just do not want to return anything, it will do something, and maybe it will print its outcome and then simply returns. Then you can also specify the type of the function as void. Okay. So if you have something like this, so you have to say return something, semicolon. But if you just declare a void, you may just say return semicolon. Okay. So of course the question is, if this function was supposed to do something without returning anything, void means nothing, then since this function is returning at the end of the body, an explicit return statement is not necessary. Okay, here it is necessary because you are returning a value. So wherever you are returning from the function, this value must be there. Okay. But if it is a void function, then when the body of the function is complete, then this return is automatic. Okay.
Excuse me, sir.
Yeah, tell.
Sir, till now you were writing return 0 at the end, so that also is similar to void?
Exactly. This is exactly the same as that. I am actually using exit 0 because exit is basically a system call. It does slightly more work than the return 0, but return 0 is perfectly all right. Okay, because the type of main is int. That's why I am returning return 0. Okay, so only thing is that if the return type is void, then an explicit return statement at the end is not necessary. Okay. Otherwise, if it returns some type like integer, float, or character, or pointer, or whatever, then even if you are at the end of the function and you know the function will now return because there is nothing else to be done, but an explicit return is not written by your code, then the compiler simply doesn't know which value to return. Okay, so here I have to specify something like this: return a value. But if it is void, since it's just returning control from the caller function to the called function, so okay. Okay, so there an explicit thing is not necessary. In all other cases, you have to specify a return value. Okay, so that's about return type. I see, maybe I switch to this mode. Yeah. Function name, this is a legal C name. Comma separated list of arguments. So that is like parameters or arguments. You may have something like this: int a, comma float f, character c, int b, and so on. Okay, it's comma separated, not semicolon separated. So I will come to the question when how I can pass arrays to pointers to functions. Okay, for the moment let's concentrate only on simple things, scalar data like individual integer, individual float, individual characters, and so on. Okay, so this is about the parameter section. Function body is like ordinary C code, a sequence of instructions involving loops, conditions, assignments, and possibly some other function calls. Okay. Okay, so that's it. And then return, I have talked something about this. So this is the standard set of instructions. This is a standard thing. Now, local variables. This I talk a little bit about. So you have a function, let's say int f something something there, or maybe I write a few variable names here, maybe int x, int y. And here I declare, let's say int z. Okay. Note that this x and y, they are also used as local variables. Okay. Z, this is anyway is a local variable. Okay. So here I can use X, Y, Z inside the body. But the moment the function returns in any way, okay, maybe because of it is end of the body or somewhere there you have some explicit return statements. I will come to examples soon. Then this X, this Y, this Z, these names you can no longer use because this X, Y, Z, these are meaningful only inside the body of the function. That is why they are called local variables. Of course, you may call this function from main, and in your main you have some variables like X, Y, Z, W, these are defined. So that is fine, because in main, in that case, this X, Y, Z, W, these things, they will have different meanings. Okay. Whereas whenever you make a function call, although you reuse the name X, Y, and Z, okay, this X, Y, and Z no longer belongs to the scope of the main function. Okay, so this is also what is called scoping.
Excuse me, sir.
Yeah.
Sir, can you repeat this point? What did you tell about X, Y, Z?
That's why I'm writing scope of a variable. So you have, let's say, your main function somewhere here. You have your function, whatever the return type is, f, blah, blah, blah. Then you have here hash includes stdio.h, blah, blah, blah. Here you have int x. Okay. So here also you have int x. Okay. So the point is that this is what is called a global variable. Okay. Whereas the variables that you declare inside a function, main is also a function, never forget that. Main is also a function. Okay. So if you declare a variable of the same name x, it now becomes a local variable. And you can use variables of the same name, x, x. You can have this. Okay. But the point is that here, whenever you talk about x, it will refer to this x, not to this x. On the other hand, if I have a global variable y here, which is not defined in main, then whenever I talk about y, I want to assign anything to y or read the value of y, do some computations with y, then that y will be referring to this global variable. Okay. So local variable, these are scopes. Okay, so these are variables defined inside a block. Okay, which means anything that appears between these is a block. Opening curly bracket, the closing curly bracket. This is a block. In particular, the function body is a block. This is a block. Okay, so local variables, these are defined inside a block. You also see that you have other blocks like in while loops, in if else statements. Inside every block, you can define a variable. Okay. And if there is a contention of the name of a variable, then which one, for example, if I say x equal to x plus plus, which x will it refer to? It may refer to this, it may refer to this. The idea is that the innermost block where this variable is defined will be the resolution. Okay. So here if I say x plus plus, this x will not refer to this x, this will refer to this x. But if I say y plus plus, and since y is not defined in main, this y, this will now go to the next outer scope. Okay. If it is defined there, then this will be meant by this y. And if it is also not defined there, then the compiler will make an error message that y is an undefined variable. Okay. Okay. So here actually we may call fx. Okay. And you may give again the same name x to this. Then whenever you say x plus plus, this x will refer to this x, not this x. And I will show you an example where we see that this x has essentially nothing to do with this x. Whatever you supply as an argument, this is simply copied to this local variable, which is also a parameter, and whatever you do it, it works in the function level, in this scope. Okay, nothing outside this. Okay, so that's about scoping of a variable. So always so which variable? The answer is that one defined in the innermost scope. Okay. For example, x is defined here. This is a scope inside this global scope. So whenever you talk about this x, it will refer to this, whereas y is not defined in the scope of the main function. But still you can refer to y, but then the compiler go to the next outer scope, which in this example happens to be the global scope. It is defined here. So this y will be considered. Okay.
So there is no way to call outer x?
No. No. There is no way to call. If you have defined something in an inner scope, you have to use that name. You have to use that variable under that name. There is no way to do it. Okay. But only one thing I would say, general advice, tell you, better do not use any global variable. And why that is the case, it will not be very immediately clear to you for the moment, because you will write, execute, and play with your I would say personal codes, and therefore you know which global variables you do have. But later, if you go to wherever, maybe industry, academia, wherever, and there you may have to share the coding exercise. Okay, so maybe you are in a big project and different persons write different modules. Eventually somebody will integrate all the modules and run the code. So if you declare some local variable, global variables like xy, that may interfere with other people's global variables. Okay. if particularly they have the same name, or there may be a lot of trouble. Okay. On the other hand, since the scope of a function is only local, whatever variables you declare inside your function, okay, this will not be accessible to other functions or globally. Okay. So it's perfectly safe to define global variables, local variables inside a function. But global variables of different codes, okay, different collaborating codes may interfere with each other. So it's not a good practice to use global variables. And I suggest that you try to code without using or without making a minimum use of global variables. In fact, you do not require any global variables in general. Okay. There are certain situations where global variables are must, but anyway. So I suggest this is a good programming practice and keep this in mind. Better not use global variables. Avoid them so long as you can. Okay. So that's an important thing. Anyway, I will come to explicit examples.
Sir, can global variables be changed inside main function?
Of course you can. Here I have to y++, right? Y
Sir,
is not defined in main.
there's an x plus x increment. Sir, is the x increment of the local x or the global x?
This is the local. That's why this is what I wrote. This is the innermost scope. If x is defined in several scopes, then the compiler will try to find the definition of x in the innermost scope. Okay.
Yes.
So, okay. So in this case, the innermost scope happens to be this. Okay. But if you write some while loop, okay, and inside you define some variable again with the same name x. Okay. So let me. Okay. Maybe I will give you an example.
Sir, for int x equals to 1. For loop.
Yeah, that's a local thing. Local thing to the for block. Okay, so I will explain. Maybe I will just give you a.
Sir, would void functions work here in C?
Yeah.
Sir, because in day 1 you told us not to use void main.
I told void main. I didn't say void f. Main will always return int.
And sir, bool?
No, bool is not a C data type.
Okay.
So I can see anything on the screen.
Mains type is int. Mains return type is int. Other functions may return void if they want. Okay, so let us see the scope. Let us say int x, y. These are, let's say, global variables 10, 20. Here you declare x equal to 30. Okay, so then you say plus x plus y. Okay, let us see what happens. Of course, at the end, it's a good practice to return something. Okay, so which is scope. Maybe with minus w or. Okay, so you see that x as a global variable has value 10. And as a local variable, it has value 30. Okay. So,
Sir,
this x may refer to this or to this, But since this is in the inner scope, so this is 30. So 30 is printed. But y is not defined here. Okay. So the C compiler will try to look at the next outer scope, which in this case happens to be the global scope. So 20. Okay, so this is 20. And then you say x plus plus 31, this x is increased to 31. And when you say y plus plus, this y is increased to 21. Yeah, there was a question, it seems.
Sir, actually, in my ID, when I used plus plus x, I got a compiler error, but I used x plus plus, I got the error, like error was removed. I don't know what happened. Like when
No.
I used plus plus x, it said x undeclared in scope. And when I used x plus plus, it was running perfect.
I don't know, this should not happen. This should
Yeah.
not. There may be some problem with it. Which ID was it? Is it?
Sir, it is Visual Studio Code.
I don't know. This should not happen.
Maybe some glitch.
Yeah, this should not happen. Under the assumption that that compiler is correct. Now what I will do, F1. Okay, so this will be executed. This may be a while for while loop also. Whatever. Here I once again declare the variable x and initialize it to 40 and y to 60. Okay, let us now see what happens if I just copy these 3 lines here. So this is yet another block because this is enclosed within a pair of matching curly brackets. I can define, so this actually, I can define variables in this new scope. So here there are actually 3 scopes, the global scope. Then within it, I have the scope of the main function. Within it, I have a new scope of this block, which happens to be the if block. Okay, so now if I do it, let us see what it prints. Okay, so here it is 40, here it is 60. So x has actually 3 meanings here. This x. It may refer to this, it may refer to this, it may refer to this. But this code demonstrates that the value of x or the meaning of x will be defined by the innermost scope. Okay. So y equal to 60. Now this time, okay, here again you see that the scope is y is not in the scope of the main scope, right? So it will go to the next outer scope and y is found here. Okay, so it's something like this. Now if after I get out of the scope of this block, this if block, okay, and once again if I want to print x, let us see what happens. Okay, it will once again print 31, 21. Because as soon as the scope of this x and this y is over, immediately the previous scope, the next outer scope, will take effect. So this x will once again refer to this x, this y will be again referring to this y. Okay.
Sir, may I interrupt once?
Yeah, again, tell.
Sir,
No problem.
inside the if statement, no sir, the code window. Can you just switch it to the code window? Yes, sir, inside the if statement, you have defined x1s and y1s again, right?
Yes.
Sir, if you just, can you please remove the x1s inside the if statement?
Okay. Let us see what happens. Let us see what happens. This one, right?
Yes.
Then x is
Exactly.
defined here and here.
Yes. Now what would
Let us see what happens. Good question.
it will go to the previous scope.
It will go to the previous one.
Yes, sir.
This is the line, right? Yeah. So X is no longer defined here. So it will go to this scope. So this will be 30. Actually, it is incremented to 31 and not this 10. Okay. 32, 31. Okay.
Got it, sir.
Okay. So maybe a few other variables would be good of different types. But anyway, you see this demonstration. Okay, so that's about scoping.
Sir, sir, here even if I don't give the if statement, if I just give the curly braces,
Yes. Yes.
then also it works.
Yes, it's exactly the same thing. Actually, it's
Yes.
like
Yes.
because if one does essentially nothing.
Yeah, yeah.
Hello,
Okay.
sir.
Yeah.
Sir,
Yes.
suppose I perform some, I have declared a variable int y in the notes which you have written, and it has not been redeclared anywhere with the same name. Now I perform certain operations on y in a function as well as inside the main. So which operation will be performed first, sir? Suppose
No.
in f I multiply y by 2 and I increment y by 1 in main. So which will be performed first?
No. What is your question?
Suppose, sir, I am performing certain mathematical operation on y inside f, the
F a
function
function.
which is declared. Yes.
Oh.
And inside main also I am making certain operations on
I,
y.
I think I understood it. No, no. I will come to that. This is actually a very, very important thing. This is called the parameter passing mechanism. You must understand this very clearly and carefully.
Sir,
Okay.
I have got an error back in like some time before when I coded. So the error said about like multiple declaration error.
Okay. Let's see. Let's see. This is another thing.
Sir, what
So,
is that? Seems like you are declaring X several times. One in global scope, one in main scope, and another in each scope.
in the same scope, you cannot have two variables of the same name, as I have done here. Okay. Now see, let us see what, yeah. Redefinition of these. In the same scope, you cannot have two variables of the same name. But into different scopes, you can always have. Okay.
Sir, since like you are allowed to read like sorry sir reinitialize X inside if, right?
Yeah.
Sir, but I have tried doing that inside a while loop or a for loop. Then also it was showing error.
No, no, no. That should not happen.
Sir, inside for loop, if I use, for example, like an iterator, that is I for I equals to that kind of that iterator. If I'm using it like twice, like for two for loops, then it would show an error saying that multiple declaration error. Yes, sir. Because I think it is not within the like the scope resolution operator. I don't mean scope resolution like curly braces. So I think it will show an error.
No, no, I
So
understand.
does that mean that for and while loop do not have a scope of their own?
No, 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 no. I will illustrate this. Okay, let's see. Okay. So this is what you do. I know that, let us make it a little bit smaller, otherwise too many lines will be printed. Okay, so let's see. So it will just print 0, 1, 2, 3, 4. Okay. Now if I once again say this, it may be a problem. Let us see. This is, I think this is what this was your question. Okay. Now in my compiler, you see that this is not issuing an error.
Sir, you are saying probably if he defines a nested loop in the for loop and then he defines the second variable also as I, he is saying that would cause a problem. No, that would definitely cause a problem. Yeah.
Problem. That should cause a
Yeah,
problem.
because you're
Because for
declaring
the nested loop is inside the scope of the first loop, so then it would cause a problem. But I had a notion like what you just did wouldn't be possible either.
This is, I am not very much sure.
Sir, as soon as the for ends, this I is also like this I value is also taken away, right? Like so it can work.
No, the point is that if I now want to print something here about I, this should raise an error.
I not
Yes, sir.
defined or something like that.
Yeah, I should. Yeah, I not different. I am. Yeah, that's true. In fact, this coding style I never use personally. If I have to use I will declare it here. Okay. But I know that many students do use this style. I am not very much sure whether this is NCC or not. I have to verify.
Sir, but if we declare the I outside the loop, then due to due to memory saving up on memory space, we actually were taught to do this. Like, if we go outside the for loop, then this I wouldn't be anymore there in case of this. But if we are
Yeah,
declared
for that,
outside the scope,
yeah,
then
no.
there.
For that matter, nobody would worried about one integer memory. These days, it's not an issue. Only thing is, my question is about compatibility with ANSI. Of course, I know that the GCC compiler supports this, and I am not very much sure whether it's a part of the ANSI syntax. Okay, so yeah, I have to verify. I do not know, frankly speaking. I never use this kind of construct. Okay, let us define I here and use it. Okay, but in a situation inside the scope of the for loop, you may have to define some variables. Okay, as I have done here. Okay. Okay, so let's not worry too much about scopes. I hope you understood different scopes and the interpretation of variables in different scopes. So it is the innermost scope. That one defined in the innermost scope. That is not necessarily the scope where you are in. You may have to go outside, then again go outside, then again go outside. Now, whenever you get a definition of a variable, okay, that will be considered as the meaning, even if it is defined in even outer scopes. And if that variable is not even defined globally, then definitely this variable is never defined, nowhere defined. Then you will get an error message, compilation error. Okay, so that's about scoping. There are many other things. Let us proceed. Okay.
Yes, sir.
Okay. Okay, if you have further queries about scopes, we will address later. Okay. Okay. But we are talking about functions. So let us do something about functions. What should I do? Let us see if sample. So what I am trying to do here, I am trying to illustrate. Say the user enters something like A, B, C, and D. Okay, so I will treat this as A by B and C by D. Later we will see how we can club together these two things in the same data type. But anyway, for the moment, let's have it individually like this A, B, C, D. Okay. Then I will write a function that will add this and this using this formula, and that will multiply this and this using this formula. So these are standard rational arithmetic, right? Okay. Now, somebody is trying to say, but I cannot hear really. His voice is too low. Volume is too low. Ranish, do you have a question? Anyway, so what I do, this is definitely the formula for adding to rational numbers. Okay. And the idea is that whenever I have computed this and this is not necessarily in the lowest terms. Okay. For example, let's say if I add okay. So if I compute this as 48, 12, 12 times 1, 1 times 4, 60 over 48. Okay. Now you know that this actually simplifies to 1 over 3. So this is what I say, not in lowest terms. Whereas this is in lowest terms. Okay. So how do you compute the expression of a rational number? That is by dividing the numerator and the denominator by their GCD. Right. Okay. So a function that computes the GCD of two integers turns out to be very useful. Int A and B. Okay, so what do? I take care of a remainder and okay. So first let me illustrate. If A is 0 and B is also 0, then the GCD of 0, 0 is actually not defined because GCD is greatest common divisor, but everything divides 0. So there is nothing greatest about them. Okay, so in this case, actually there is an error, but in order to handle this, I will just return 0. In fact, this example illustrates that. Then I will write the actual GCD code. Okay, this actually illustrates that I can have this return statement. Okay, even if it is a value or simply return semicolon, if it is a void type, so I can have that anywhere. Okay, not necessarily at the end. Then what I will do, I will assume that A is greater than B. Therefore, if B is greater than A, I will just swap A and B. Okay, so this is the standard routine. R equal to A equal to B, B equal to R. Okay, maybe a little bit more I have to do.
Hello, sir.
Yeah, tell.
Sir, instead of returning 0, can we exit in the function itself?
You can exit. Definitely you can exit. Yeah, you can exit in the function. Yeah.
Okay, sir.
Yeah, you can exit. But then your program will terminate.
Yes, sir. I would want to do that because I cannot divide by 0 anyway.
Yeah, that's true. That's true. Anyway, so we will handle this little later. You may handle it here, but when you are computing the GCD, definitely you are not immediately trying to divide by 0. Okay, so let us not worry too much about exit 0 here. Maybe we will do it somewhere else. Okay, So if B is greater than A, so at this point I will I know that A is the bigger of the two and that is non-zero. But B may still be 0. So I will simply write while B, so long as B is not reduced to 0, I will do A%B. This is defined because B is non-zero. Okay. And then I will make a switch. A equals B equals means assigned B, B assigned R, and this loop will eventually break when B becomes 0, but at that time A stores the GCD. Okay, so this is the Euclidean loop. This is first of checking of an error condition, but this demonstrates that I can have a return statement anywhere, not necessarily at the end. Okay, I can have the return anywhere. Okay. In this example, of course, this is a return because of an I would say error. Okay, but this return may be actually I would say deliberate, I mean intentional, even if it is not motivated by any error condition. Okay, otherwise, if this is not the case, you simply run this Euclidean GCD loop and return the GCD. Okay, so you see that these are two arguments A and B. They are both int type. The name is GCD. I can use this name GCD because it is not a CEC, I would say, reserved word. Int type is int. R is a local variable. And this A and this B I can use as local variables, as I have done here. I have changed their values. Okay. Eventually I return something. Okay. So now maybe I just scanf. Okay, so maybe I use another temporary variable t. Okay, so in t, I compute the GCD of A and B. Okay. Now here I check. So I will divide A by T and B by T so that the fraction A by B is in lowest terms. Here actually I can do that check. If T equal to 0, T is equal to 0, maybe I just say exit 1. Otherwise, I divide A by T and B by T. Okay. So maybe I write it in a single line. So this is the reduction of A by B to the lowest terms. Then I will do the similar thing for C and D. Okay, so maybe I write something here. So this is before reduction, A, B, C, D. And after reduction, I have this. Okay. Let us see, this time this name is rational. Okay, so let us not worry too much about negative values. Let us work with only positive things. Let's say 4 by 8 and 4 by 6. Okay, so before reduction it is 4/8 and 4/6. After reduction it is half and 2/3. Okay, so this example immediately demonstrates some usefulness of functions. I have called GCD twice. If I did not have this function, I will have to write these many lines of code here once and here for a second time. So functions, if called multiple times, okay, save a lot of coding, right? Because GCD is the same function. Mathematically, it is the same function. So writing the entire code of the function here and the second time here is not a good idea, right? Okay. So maybe here I just mention y functions. So avoid repetitive codes. And the second, use of functions is what is called modular programming. Okay, if you write a very huge main function, okay, extremely huge, maybe running for 100,000 lines, something like that, it's not really very, I would say, readable. Instead, whatever you are doing in your main function, you break them up in some chunks of, I would say, meaningful computations and embed each chunk in a function. And in your main function, you just do the input output and make function calls. Okay. So modular programming is actually a very good practice. Okay, so possibly you will not understand exactly what is meant by modular programming, but the idea is this: instead of writing very long codes, you just break them up into chunks, and for this chunk you call a function, for this chunk you call a function, even if they are not repeating. They are different things. Okay. Anyway, so let us proceed with our another function. Rational add. Okay, so you actually did never raise the issue. Here I have called GCD with these arguments A and B. Of course, I could have called them with any other uh, any other.
So data type.
No, not data type. What I'm saying is that instead of only A and B, you could actually pass expressions like A plus B, A minus B, C star D, D by B. Okay. So anyway, I will come to that. But here you see that I am changing the values of A and B. Okay, A becomes minus A. Then you replacing A by B, B by R, and so on. The idea is that nothing will happen to this A, B, C, or D. Why? I will come to that little later. Okay. Okay, so rational add. So you now have X and Y. What is the formula? X will be this, AD plus BC. And Y will be BD, right? So what I will do, I will print A by B plus C by D is equal to percent D by percent D X and Y. But then what I will do is that once again I would like to reduce this X by Y fraction to lowest term. So once again I will compute, I will use something like T.
Sir, why does this function return int?
Oh,
It is just void return.
yeah. Actually, I cannot return two things like X and Y.
Yes.
In this fashion. It can be done, but we'll see later. Sorry. Okay. Yeah, this it will just print and it will be done. Yeah, this is void. Okay. T is again GCD of X and Y. And I assume that A and B are valid things. Otherwise, you once again say if T equal to 0. Okay, maybe I just write it. Just copy here. Then exit. Here instead of A and B, I will say X and Y. So I will complete this line equal to percent D by percent D, and then new line, and then I once again write X and Y. Okay. Now 8, 4, 6. Oh, sorry. Okay. I have to call this function R add ABCD. A, B, C, D. 4, 8, 4, 6, right? 4, 8, 4, 6. So half plus 2/3 is this, right? So let us do something where I have some kind of reduction even there. Maybe let it be, for example, we have seen 1/4 over 1/12. Okay. So maybe 2/8 and maybe 3/36. Right. 1/4 is 2 over 8. 1/12 is 3 over 36. Now let us see what happens. Okay. So it's 2 by 8. This is this. 1 by 4. 1 by 12. This is in lowest terms. Then you first add them using the standard formula. You get 16 over 48. And then if you divide the numerator and the denominator by their GCD, you will get 1/3. Okay. Okay. In a similar fashion, you can write the product of two. Just copy, paste. Instead of R add, I will have R multiplication. Only difference is that this will be A star C. A star C and B star D. And let's say star. Okay. And once again, if you do not call it, nothing will happen. So you have to call mul. 2, 8, 3, 16. 2, 8, 3, 16. 36. Okay, now there is no reduction, right? So what I will do, you will just call 2, 8. What do I want? 1 over 12. 1 over 12. 13, 25. Okay, nothing is working. What about here? 1 over 4, right? 5 over 4. Just let me work out. 1 over 4, maybe 9 over 4. 9 over 4. 1 over 12. Okay, so this will demonstrate it. So 4 is 9 over 4, so maybe I give 18 over 8 and 336. Okay, so it is 9 over 4, 1 over 12. If I add, this is after simplification, it is this. Multiplication, before simplification, it is this, and after simplification or converting to lowest terms, it is this 3 over 16. Okay. Okay, so the idea is that this program demonstrates both the good programming techniques. First of all, both these two points. Avoid repetitive codes. So I have used GCD 4 times, right? Once here, once here, once here, and once here. So instead of write those some 10, 12 lines in each of these 4 places, it is a good idea to have a function for this and call it appropriately with whatever parameters we want. Second, radd and rmal were used only once, and therefore they could be defined in main itself. But just for, I would say, readability, I have simply encapsulated, or encapsulated is actually a reserved word anyway. Let's say I have just okay, something like enclosed this code for radd, and I just call radd from main, rmal from main. Okay. So this demonstrates the second thing, modular programming. Okay. Okay, so there are many other things, and this is 416. This screen is black. Is this a question?
Yes, sir. It went black for a second, but then it reappeared.
Oh, okay. Oh, it's fine now, right?
Yes, sir. It's fine.
Okay. So I believe this program demonstrates not only the declaration and use of functions, it also demonstrates these two issues: avoid repetitive codes and modular programming. Okay. Okay. So that's it. So this is one thing about functions. We will look at some other things. Shall we have a small break, a 5 minutes break? Okay. So I will come back after 5 minutes. Okay, I am back. Okay, so let us continue. Okay, for the rest of today's class, I will demonstrate and explain at least two other things. One is parameter passing mechanism. Okay, I told about argument and what did I talk about? This argument parameter. Okay, parameter I have told. Okay, so fine. So parameter passing mechanism. So what is important here to note is that in C, this is always what is called call by value. Always. There is no exception to this. All parameter passing is call by value. Okay. So what does it mean? Once again, let us look at this. Maybe this code. Here I am calling it with A and B. Here I am calling with C and D. But I can support, I can supply any arbitrary expressions like C plus D, D plus D. Okay, things like that. And here I have some formal variable names A and B. So the idea is that whenever you make a function call and supply its arguments, something like here, of course, I have used individual variables for the GCD functions, but I could have simply passed a star D plus B star C as X here, B star D as Y here. Okay. So whatever this AX or Y or this quantity, if I pass that way, it is evaluated, and that value, whatever this is, argument is, that value will be used to give the initialization value for this variable A. Likewise, whenever I look at the second argument, it is evaluated. Okay. Here, of course, this is just Y, but I could have passed it as B star D. Whatever it is just evaluated, and that value will be used to initialize the value of B. Okay. Now, inside this function, it is completely irrelevant how this value A or how this value B is evaluated outside it. Okay. This may involve variable names, expressions, whatever, but those variables that are used in the evaluation, they have absolutely nothing to do with these values or variables A and B. Okay. So I will demonstrate this first using an animation. Parameter, yeah. Okay. So this is actually a bad way of attempting to swap these two values A and B. So I want something that will, after a function call, that will allow this 51 value to go to B and the 23 value to come to A. Okay. Now apparently I have done something very wrong. This is because this call by value. So I just called bat swap A comma B, and inside this I am just writing the standard swap routine, temp equal to A equal to B, B equal to temp. Okay. But the idea is that this A and B, they get swapped. But this A and B have nothing to do with this A and this B. Okay, they are in different scopes. This is in the scope of men, this is in the scope of bad swap. Okay, 51 is copied as an initializing value for this A. 23 is copied as an initializing value for this B. And this A and B are different variables than this A and this B. Whatever changes you make to this A and this B, these changes will not be reflected in this A and this B, although they have the same name. Okay, so let us see what happens really. Okay, so in men, you define two variables, A initialized to 51, B initialized to 23. Okay, then you call this, okay. So you're calling this function. Okay. So what happens, this creates a new scope, which is actually not inside the scope of men. This is disjoint from the scope. Here you have some A, which happens to be the same value as this A. Okay, 51. And this B, this happens to be the same value as this B. But this A and this B, they are in the bad swaps scope. Whereas this A and this B, they are in main scope. Okay. Now here I declare a local, these parameters are just copied by value. That is what is meant by call by value. Their values are copied. Their references are not copied. Okay. Now next, let's see what happens. Next you define a local variable TMP. Then you assign TMP equal to, say 51 will come here. Okay. Then you say A equal to B. So this 23 will come here. 23 will come here, and eventually you will say B equal to 10. So this 51 will go there. Okay. Of course, I have shown this as a faded thing just for the effect. Okay. Actually, the value 51 continues to stay here. Okay. So this apparently has produced the desired effect of swapping A and B, but it is this A and this B that are swapped. Nothing happens absolutely to this A and this B. They remain as 51 and 23 as before. Okay, so returning, nothing happens to this A and this B. Now tell me if you raise an issue about it.
Sir, in this case, global variables could be helpful if we do not just pass.
Yeah, this is one way of solving this, but
also pointers can be helpful.
Yeah, pointers we will actually use.
Yeah.
So, but since we have not introduced pointers, let us, for the moment, not worry about how to fix this problem. But there is a problem. This is what I would like to highlight. Whatever value you pass, the value, these arguments are first evaluated, and that value will go to initialize this formal parameter. It is absolutely irrelevant how this value is computed. It may be the name of a variable or maybe more complicated expressions. That doesn't matter. Okay. Whatever changes you make to this A and B, these will not be reflected outside the scope of bad swap or your function call. Is that clear? Let us not try to fix it, because fixing it requires a little bit more machinery. Okay. It appears for the rest of this This is the actual way. This is the way how you can do it. But let's not worry too much about how this can be actually solved. We will come back to this when we talk about these things like pointers. Okay. Okay. So first, let me understand that you understood the problem. Once you understood, you will see a solution soon, maybe within a couple of weeks or something like that. Okay.
Sir, I have a doubt.
Yeah, tell.
Sir, in main when we call a function, is it necessary that we pass variables? Can we pass constants like GCD of 3,7?
Any expression you can pass. It may be a constant, it may be a hash defined constant, it may be a variable, it may be a very complicated expression. It can even be the output of a function call. Okay, so you can actually pass what things? Let's say you can pass GCD A, B. You can pass this as GCD 5, 10. And any mixture. You can also call GCD A plus B. And if you have something like hash defined C, 10, you can use C here. This is allowed. Even if you want to compute the GCD of 4 numbers A, B, C, D, you can call this as GCD A, comma B, comma GCD C, comma D. Okay. All these things are allowed because this GCD A, comma B will return an integer value, and that can directly be passed to this invocation of GCD. Similarly, this one evaluates to an integer value, and that value is returned. That thing can be, instead of saving anywhere, you can pass it to this, to the second argument of this GCD. Yeah, this is an important question I forgot to mention. Yeah. Is it clear now?
Okay, sir. Thank you.
Yeah, I actually forgot to mention this. Yeah. Thanks for
Excuse me, sir.
Yeah.
Whenever I call a function from main, when I compile it, the compiler gives a warning. So, is there any way to avoid it?
No, I didn't understand your query.
Sir, whenever a function is called, when I compile the program, a warning arises that implicit declaration of function, something like that.
This is here. There are so many things. Okay. So, okay, maybe this is the next question. Okay. Yeah. There are so many issues related to functions. Okay. Okay, so this is fine, right? So as arguments, I am of course allowed to use individual variable names, but I can pass constants, expressions, or even values returned by other functions, or any other thing. Something like this is also allowed. GCD AB plus 10, 5. This also you can do. Okay, so it's perfectly okay. Because this evaluates to an int value, I simply add 10 to it. Whatever it, I can pass it as an argument. And of course, I can do it, this constant, or a hash defined constant like this. These are all fine. These are all allowed. But definitely, if some function returns void and some argument is an int, therefore you cannot use. Okay. For example, if this r add, this returns void, nothing. So I cannot pass this r add a comma b comma c comma d here. Okay, this does not evaluate to any integer value. That is not allowed. Okay. So with respect to that code, this r add abcd 5, this is not allowed. Because in the code we have seen this return type is void. Void cannot be converted to an integer. Okay. But before that, whatever you have done, these are all legal. This is not legal. Okay. Okay, so that is one question. Second thing is this, just let us do this. So, yes. Function prototypes. Okay. So, if you look at this code, I have used GCD. Sorry, I have defined GCD before I have used it. Okay. And here also I have used it, but this is strictly after the definition of this GCD function. And you here see GCD, they are already defined. Here also you see that radd and rmal are defined earlier. Okay. So what happens if I just bring this entire thing to the front? Let's see. How many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 lines. Okay. Let us see. Let us try to compile and see what happens. Okay, this time compilation is important. Okay. So you see a lot of warning messages have come. And let us see. I remove that a dot out. Let us see. No, a dot out is actually created. But you see there are a lot of other things. So, first of all, implicit declaration of a function GCD. GCD. Okay, AB. Because I have used this before defining. Right. Likewise, here I see radd. This is implicit declaration of radd. Now this is these days everybody is artificially intelligent, so it's thought maybe I have made a mistake. Instead of radd I meant rand, but this is not a typical behavior. Okay. So GCD, radd, okay, they are all implicitly defined. Okay, because the C compiler sees that I am using it without explicitly defining or declaring it. Okay. Now let's see what happens if I go a little further. It says conflicting types for radd, conflicting types for rmal. Okay. Whereas it does not issue me the same warning message for GCD. Is that clear? Implicit declaration, this warning comes for GCD, radd and rmal, all three of these. But only for radd and rmal, I am getting another message that is they are of conflicting types.
Why is this happening?
Yeah?
Why is this happening? Conflicting types?
Yes, I will explain. Why is this happening? For GCD, I am not getting this message. radd and rmal, I am getting this message. The reason is this. Use a function before defining. This is what is meant like this, implicit declaration. So this issues the warning message, implicit declaration. The idea is that this is not exactly very, I would say, unallowed in C. This is allowed. Okay, allowed, but since the C compiler does not know the prototype of the function, that is its input-output behavior, it implicitly assumes, okay, whenever it sees a new name, okay, a new function name before its call, it implicitly assumes, the compiler assumes that the return type is int. Okay, because the compiler still does not know what the function is, how it looks like. Okay. And therefore, it has to make some assumption in order to proceed, and that assumption is that the return type is int. It remembers, I have seen a new name, and I assume that its return type is int. Int is the valid, is the only guess that the C compiler can make. Okay. Later, when this part is compiled, it looks or encounters the definition of GCD and sees that the return type is actually int. So it's fine, no problem. Okay. So the earlier guess that the return type is int is verified. And so the C compiler is happy and does not issue any other message against this GCD function. But when it next comes to this radd, it sees that the return type is void. But earlier, when it actually encountered a use of this function, it assumed that the return type is going to be int. But now it sees that the return type is void. Therefore, you get this error message for radd and rmal, but not for GCD. Okay. You now try to understand this exact whatever it says. Implicit declaration radd, implicit declaration rmal, warning, conflicting types for radd. Here it sees void, but the previous implicit declaration of radd was this. Okay, and there it assumed that its return type is int. Now it sees void. So now it issues this warning message. Rmal, okay. This void type contradicts the previous implicit declaration. Okay. So that is the reason this thing happens.
Sir,
It happens for radd and rmal, but not for GCD. Yeah, tell.
sir, suppose if I if I define a function prototype where I do not mention the return type, will it can I return integer values from it if I without any error?
I think it will not compile.
Okay.
Or it defaults to void. Let me try and see what happens.
But you said it
Let us
assumes
see.
it.
Let us see.
Okay, yeah.
My function int a, int b. Let us see whether it compiles. I think it will not compile. Warning return type, defaults to int.
That is given as a warning only.
Yeah, but if it has that rule to make to default it to int, then of course you can return an integer value. Okay. Okay. So if you do not specify anything, it means int. Okay. But please verify with this ANSYS specification whether this is the ANSYS you would say recommendation or this is what my compiler is doing.
Sir, how to get those recommendations? Like a lot of books say a lot of things different. Sometimes it contradicts.
First of all, Corning and Ritchie is the authentic book on C because Dennis Ritchie designed the C language. So, but that was in 1970s C. Later, there are several C, newer specifications. So this must be there somewhere. Okay. Anyway, let us try to avoid doing these tricky things. Okay. So essentially, you are learning programming, solving problems. Of course, we have to use some language. That's why we are using C, but it doesn't matter. Okay. Okay. So now what can I do so that all these warning messages will go? This is what is meant by a prototype definition, declaration. So this is what is called function prototypes. You don't have to define the function body here, but you just mention that at some point of time, will define a function whose input output behavior is like this. It will return int, it will take one int and a second int as arguments or parameters. Okay. Now let us see that this initial warning about GCD, this will go. Okay. Now the complaint is only about radd and rmal. Okay. So if I now also define the prototypes for radd, but it should match in four.
Sir, void. So it should be void aren't.
Oh, sorry, void. Radd and rmal. Okay, so these are called function prototypes. You may or may not give some names int x, y, z, w, whatever. This did not match even whatever you have written here. Here you have given a, b. You can definitely write int x, int y. But whenever you are declaring prototypes, you are just telling the compiler this is the input-output behavior of your functions, and therefore the names that you use here, they are of no use.
Excuse me, sir.
Yeah.
Sir, why you used wide radd and wide armor?
Now if I compile it, see, all errors or warnings are gone. No, void because my functions radd and rmal are supposed to print certain things, but they are not meant for returning anything. Therefore, I used void. Because if the return type is int, then I have to return something, but there is nothing meaningful to return in this context, right? GCD, of course, this is a single integer value that I am going to return. The radd and rmal is basically printing the sum of two rational numbers or the product of two rational numbers. Okay. So is that fine? So function prototype. Okay, fine, good, thank you. So if I now declare this function input-output behavior, of course, it doesn't matter. I can use some names here. And they need not match. I'm using X here. I am using A here, and I have not used any name for this second one. Then also this is not a problem. It will perfectly. It will simply ignore the name here. Okay, because the name has no role to play in this prototype declaration. It only keeps the C compiler happy because it now knows int are the two integer things, input, and the output is int, void. Later, when it actually sees the declaration, then this thing should match. Int should match int, this int, they should match int. All of these four things should match. Now, if you declare something like float here, whereas in the actual declaration you have int, then let us see what happens. Now it's actually an error. Right? This is not even a warning. It's an error. Okay. So,
Sir?
Yeah.
Sir, can we define like two functions here with one with int, one with float, like overloading type?
No. This is not allowed in C. It is not C++. This is not allowed. In the same scope, you cannot use the same name to define two different things like variables, functions. Variable name must not match a function name in the same scope. Of course, it's a scope of, okay, forget about that. Yeah. So if you, this is what is called function prototype. I hope it's understood, right?
Yes.
Okay. So this is not the body of the function, but it just keeps the compiler happy. Okay. And you see that this is the reason why you have hash included stdio.h. This is one of the reasons I would say. And this is one of the reasons. Okay, why? Because the functions that are declared, they are like printf, scanf, getchar, and all this stuff. Okay, they are defined. They are not actually declared. They are not actually fully defined, but they are only declared in this stdio.h file. So if you, for example, I show it typically resides in some system directory, not etc. It should be in include maybe. No, user include stdio.ch. Okay, so if you look at this, you will see many things hash include it's okay. You will also see okay, yes. For example, you will see certain function prototypes like this. External, let's not worry too much about extern. For this course, you will actually not require. The return type is in, something called remove, and this input output behavior. Okay. Okay. So, and also in this thing, maybe printf is not defined here. Let us see. Oh, okay, it's defined here. Fprintf is defined here. Anyway, yeah, printf is defined here. Okay. An input string followed by ... means an unknown number of parameters. So essentially by including hash including stdio.h, you are essentially bringing everything in the scope of your program. So now the compiler knows printf actually is supposed to return int. It will not issue any warning message. Okay. Yeah, something like this. This is one important thing, function prototypes. And because stdio.h and stdlib.h, they define a lot of such function prototypes, like here, printf, scanf. It's a good idea that you always hash include those things. Without this, the compiler will issue many warning messages, as we have done. Okay. And second thing is that there is one situation where these prototypes are actually necessary. Okay, so you know this is a chicken and egg problem, right? Which one came earlier? So let's say that a function called chicken calls a function called egg, and a function called egg. This also calls the function chicken. So without prototypes, which one will you define, or earlier? Because this calls this, so this should come before this, and this calls this, so this should come before this. Which one should come earlier? This is impossible.
Sir, whichever is called earlier in the code, in the main.
No, that is fine. That is fine. So in main, Maybe you call chicken first.
It's stuck in an
But
infinite
in the
loop
definition of chicken, you are calling egg.
because both are dependent on each other.
Yeah. And in egg, you are calling chicken. And suppose that, yeah.
It will go on and on.
Yeah. So it will issue some warning message, make some implicit assumptions, and then try to verify later that this assumption is valid and blah, blah, blah. And there may be errors, there may be warnings, lots of bad things may happen. Okay. But if you, before declaring this chicken function and egg function, you simply write their prototypes, the compiler is happy. You just tell your intention. I am going to use a chicken function whose prototype is like this, and I am going to use an egg function whose prototype is this, but somewhere this must be defined. The body must be there. Okay. So that's important. Another issue. I'm unable to start recursion, but maybe I'll just take another 10 minutes to demonstrate passing arrays to functions. Okay. So let's say I have in main, I have an int array. Okay, and I will write a function. Maybe this here I have good space. So whatever it returns, maybe it returns int f int array, and maybe its actual size that you are using it. Okay, and here when you call, maybe here you have n like this. First of all, this is the mechanism. So this return type is like as before. And here you have to use this opening and closing brackets in order to indicate A is not an int, but it is an array of int. No necessity to, I would say, for the moment, no necessity to give a size. Okay. But if you want to use first 50 elements of this array, then you must specify that size by in this external variable n. Okay. So this is the mechanism: type, name, followed by opening bracket, closed bracket, square bracket. Okay. No need to specify any size. You can say 50 here, 1 million here, something different from this. It does not matter. The compiler will simply ignore it. So better not give any size. Okay. And when you call, you just use this name of the array. Okay. So in function, you should have this. And when you call it, know this. Just pass the name. Okay, do not pass this anything like this. It's not A, something like this. Just pass A. So this is the mechanism. And here there is something a little bit different happens. So let me explain this using this. Yeah. Okay. So let us look at this example. So I am using a string in a character array of size 10. Okay, so this is actually string library function defined in string.h. So I'm copying this string tijihba to this string name, and I'm just calling reverse name. Okay, Now here I mentioned that you are sending something like n, but when I am talking about strings, I do not have to use the size of that string. Why? You tell. What is the size actually? 1, 2, 3, 4, 5, 6, 7. Why do I not needed to send the size in a separate thing?
Sir, address is first.
Yes, because it sends the
That-
pointer to the first element.
No, no, no. This happens here also.
So we have to declare only the types. Hence, there is no need of number.
My question is different.
So because it has a terminating character.
Yes, so that's the correct answer. Because we are dealing with strings, there is a terminating null character at the end of that string. Okay. And using that terminating null character, you can actually identify its size. You do not have to explicitly mention it here. But if it is an integer array, either you follow a convention like that. Okay, after that you have some null integer, maybe -1, something like that, or you have to specify the exact size of that array that you are going to use. Okay. Okay. So this is one thing. Anyway, that is typical of character arrays only. Let us see. So in main function, you have an array called name. Okay. And then you are copying that standard constant string to this array. So TIJIHPA, and that null character will be there. Okay. Of course, I have not shown it. Okay. It is there. Null character. Okay. Then I call this reverse name. Now earlier you have seen I have mentioned that whenever you are passing some int value, that is okay, the value is copied to the parameter. Okay, so if I pass something like 7 here, that 7 will be copied to this n here. Now whenever I pass an array, it is not that this entire 10 element array is copied element by element to this. What is copied is indeed the address of the 0th location of this. Okay, this is the reason, this is why I will explain maybe a few days later, few weeks later, because arrays are nothing but pointers. Okay, so if I make this function call, this is main memory, right? Mains memory. Now this is memory of reverse. It does not get a copy of this entire 10 element array. Instead, in this A, it gets a pointer to the first element of A. Now the idea is that inside this function, whatever change you make to this pointer, this is not reflected outside. But this pointer is pointing to this array, and therefore if you make any change in this array, that will be reflected from outside, that is from main. Now I want to reverse it. So I just swap T with A, I with B, J with H, and this I is not needed to be swapped. So this is just what this function is doing. It's fairly straightforward. I, L, and C are two local variables used by reverse. Okay. This is once again a standard string function, string length, strlen, that assumes that this is null terminated. So calculating length of string defined in string.h comes to 7. Now it's a standard loop. You can see first T and A will be interchanged. T and A are interchanged. Then I and B are interchanged. I and B are interchanged. Then J and H are interchanged. And that's all. Exiting loop. So if you pass an array, the array elements are visible inside the function. If you make any change to that array, it directly affects this array. Okay, so that is quite unlike that bat swap function. Here, any swap you make between A and T, this will be visible from outside because the array is not copied element by element. Only there is a copy of the address of the first element of this array to this pointer called A. Okay, but you can write, for example, Department of Computer Science and Engineering, IIT Campus, Kharagpur 7210302, India. Wherever you write it, if you want to access that location, it may be written in a mail in front of maybe a bus ticket, wherever it is written. Whenever you want to go to access that location, it means a particular point, right? The Department of Computer Science and Engineering, Indian Institute of Technology, Kharagpur 7210302. Okay, so you make any arbitrary number of copies of that address, but still whatever it is pointing to, that is precisely a particular place, right? Therefore, if you change A, this pointer will change. Okay, but if you change A0, A1, A2, A3, these are visible from outside. Is this concept clear?
Yes, sir.
Okay. So you see how you actually pass arrays. Just use the name, no brackets, nothing. Here you use brackets. Okay. There is no need to specify any size here because after all a pointer is copied, whether it's pointing to a 50 element array, 100 element array, 200 element array, it's absolutely irrelevant to the compiler because only this pointer is copied. And if you change this pointer, you may change this pointer, nothing will happen to this pointer name. But whatever this pointer is pointing to, if you change those locations, this will be directly visible from this main function. This is also called by value. This is not called by reference. Okay, but in this case, call by value is essentially which value is copied. It is the address of this is copied, and this is how essentially C handles call by reference. Okay, we will look at more about pointers later. Okay, so I hope this is up to this point it is okay.
Sir, how is call by reference different from passing an address?
This is actually a critical, I would say, not critical, it's a subtle issue. It's a little difficult to explain because C does not have anything called call by reference or call by name. It is essentially something like very difficult. I don't know how, because you do not know Pascal, right? Pascal has one kind of parameters called var. So, for example, in GCD, if I have something like that, so if I have that var int a, okay, and I call it as GCD xy, then that x and this a, they will essentially point, or not point, I would say, they will essentially mean the same variable. Anyway, let's not worry too much about that. You must understand that it's always called by value. Even in this case, it is called by value, but what is copied in this case is not this array, but its first address. And therefore, although this A is a copy of the address name, it does not matter. A and a name are pointing to the same location. So if you make any change in this location, this will be reflected in this array also. Okay, so that's the message. Okay, so tomorrow we will start something more complicated. These are called recursive functions. Let's see how much we can proceed. Otherwise, if we cannot finish, we'll continue to the next week with functions.
I just wanted to reconfirm the test date.
Same thing. I think it is 28th, right? This Wednesday. I got one or two requests about having it in the class, regular class hours, but for fairness, we want this to happen, simultaneously for all the 10 sections. And some of the sections are doing this PTS class on Mondays and Tuesdays, and the others are doing in another slot, Wednesday, Thursday, Friday. So there is no common slot for everybody. We have to use some other time. And
so can you put it on Sunday, sir?
No, Sunday or whatever.
No, sir. Why Sunday?
No, that's even more inconvenient. So it has to be sometime outside this regular class hours. Also, you note that out of these 10 sections, everybody will have at least one section will have, or not at least, exactly one section will have its lab in each session. Monday morning, yes, one. Tuesday morning, one. Monday afternoon, one section. Tuesday afternoon, one section. So there is no other choice for us. We have to go beyond class hours. So I know it's a little bit inconvenient, but please understand this inherent limitations of us. And we want the entire test to happen together for fairness. Okay. So this time and after midsem, another short test will be there. So these are the 2 half-an-hour slots that we request you to manage in the evening, but on working days. And your midsem and sem will run as per institute's schedule.
Sir, what will be like the test of the midsem and sem like pattern wise?
Oh, we have not decided, man. Let us see.
Okay.
Let us proceed one by one.
Yes, just curious.
Yeah.
So one more thing, so in the short tests, will like questions like this based on tricky like declarations and initializations and all the tricky concepts based exclusively with C, will they be asked?
Tricky means not the extremely tricky ones like what happens when you say A++ plus B plus A, things like that. Things that are not defined will not be asked, but yes, certain things will be asked. Okay.
Okay, sir.
Which do not have any, I would say, any ambiguity. Ambiguous things will not be asked. This is for certain. Yeah. If you have any other questions, please let us know. Let me know. And otherwise, let us.
Sir, what will be the total marks of coordinates test?
Forget that. We ourselves have not decided. We will see. Also, the institute has some recommendations. We will follow that.
Sir, actually, I had a question. Where can I find the slides of that you upload, like with these note slides?
What slides means?
Sir, like last day you were showing some notes where some programs were done, PPT.
You look at this web page, right? Where is it? Somebody has written it.
If someone has it, can they share it right now? That would be great.
Share it, but I have to go.
Yeah, sir, I got it.
Okay, Got it. Okay, so go there and just today's slides are not there, but I will upload it after the class. Yeah, this one. CCID is based in PDS or tilde PDS/current. Okay. Yeah, but my suggestion is that you go through the slides after the classes, because it is impossible for me to cover everything. And I am not very comfortable with just opening the slides and read it out. That's not my way of teaching. Okay, so.
Thank you, sir.
Okay, so let us call it a day. Already a long session.
Thank you, sir.
See you tomorrow again.
Thank you, sir.
Okay, thank you.
Thank you, sir. Thank you.
Okay, so I will stop presenting and recording.